Imagine witnessing the final moment of the universe. Not your final moment, the universe's, not millions, not billions, not even trillions of years from now. Picture a future nearly impossible to comprehend, around 10 years from today. A span of time so vast that writing the number in full would require more zeros than you could ever meaningfully imagine. By then, every star has burned out, every galaxy has gone dark, every planet has frozen into silence. The last surviving black hole, the final giant left in existence, has been evaporating for longer than human language could ever describe. Then, at last, it releases its final photon, one tiny particle of light. The last physical event the universe will ever witness. After that, nothing, no stars, no galaxies, no heat, no motion, no sound, no life, only an endless darkness stretching forever through space, with no observer left to notice it. This isn't science fiction, it isn't a religious prophecy, it's the destination predicted by modern cosmology. According to everything we currently understand about thermodynamics, general relativity, and quantum physics, the universe is moving toward a state known as heat death, a future in which all usable energy has been exhausted and no meaningful change can ever happen again. In other words, the universe has an ending. That alone is astonishing, but it raises an even stranger question. If the universe was created by an eternal, infinite God, why create something temporary? Why would an infinite creator build a cosmos designed to expire? It's a question that sits at the intersection of physics, philosophy, and theology. And surprisingly, very few people stop to ask it. Most debates about God revolve around whether he exists. Far fewer ask what his creation reveals about his intentions. Because if God is timeless, why create time? If God is unchanging, why create a universe defined by change? If God exists beyond decay, why create a reality governed by a law that guarantees everything eventually falls apart? At first glance, it feels like a contradiction. Shouldn't infinity produce infinity? Shouldn't eternity create something eternal? Yet every observation we make points in the opposite direction. Stars are born, and they die. Mountains rise, and slowly erode back into dust. Oceans shift. Continents drift. Even atoms are not guaranteed to last forever. Nothing around us appears permanent. We've become so accustomed to this pattern that we rarely question it. Everything ends, it feels obvious. But obvious things often hide the deepest mysteries, because if every created thing eventually disappears, then perhaps the ending isn't a flaw in creation, perhaps it's part of its design. Before we can explore that possibility, we first need to understand what modern physics actually predicts about the fate of the universe. Because the way the universe dies may reveal something profound about why it exists at all, and what we'll discover is unexpected. The law that ultimately destroys everything may also be the very law that makes life, consciousness, love, and meaning possible. To understand why the universe ends, we first have to understand the rule that governs everything inside it. Every collapsing star, every beating heart, every burning candle, every thought passing through your brain, all of them obey the same principle. Physicists call it the second law of thermodynamics. Despite its intimidating name, the idea is surprisingly simple. In every closed system, usable energy becomes less available over time. Order gradually gives way to disorder. Heat spreads, energy disperses. Nothing stays exactly as it is, and, as far as science has ever observed, this process has never been reversed. It's one of the most thoroughly tested principles in all of physics. From laboratory experiments to the evolution of galaxies, every observation points in the same direction. The universe has an arrow, not an arrow through space, an arrow through time. There is a past, there is a future, and the two are not interchangeable. Without this one-way flow, cause and effect would lose their meaning. Memories couldn't exist, evolution couldn't unfold. Even the concept of before and after would become meaningless. The universe isn't simply expanding, it's aging. Every second that passes is another step toward a future where less usable energy remains than before. And that future unfolds in remarkable stages. The first age. The age of stars right now, we live during an extraordinarily special chapter in cosmic history. Astronomers call it the stelliferous era, the age of stars. It began shortly after the first generations of stars ignited, transforming a dark, simple universe into one filled with light, chemistry, and eventually life. Stars became cosmic furnaces. Inside their cores, hydrogen fused into helium. Later, heavier elements formed: carbon, oxygen, silicon, iron. The atoms that make up your bones, your blood, and the device you're watching this on were all forged inside ancient stars that died billions of years before Earth even existed. In a very literal sense, you are made from stellar ashes. But stars are not eternal. Every second, our sun converts hundreds of millions of tons of hydrogen into helium, releasing enormous amounts of energy into space. That energy warms our planet, it drives our weather, it powers every ecosystem on Earth. Yet every burst of sunlight is also a reminder that the sun is consuming its own fuel. Its brilliance is inseparable from its decline. One day, about 5 billion years from now, that fuel will run out. The sun will expand into a red giant, engulfing or scorching the inner planets before shedding its outer layers and ending its life as a white dwarf. What is true for our sun is true for nearly every star in the universe. Some burn gently for trillions of years, others explode after only a few million, but none burn forever. The age of stars itself has an expiration date. Roughly 10 trillion years from now, almost every star capable of shining will have exhausted its nuclear fuel. The lights of the cosmos will begin to go out, one by one, galaxy by galaxy, until new stars can no longer be born. The universe will enter a second chapter, one far colder and far darker, say the second age. A universe of courses. Imagine looking into the night sky and finding no new sunrise anywhere in the cosmos, no brilliant young stars, no glowing nebulae, no worlds bathed in fresh starlight. Only remnants, white dwarfs slowly cooling into black dwarfs, neutron stars silently drifting through space, frozen planets wandering without suns. The universe won't end with an explosion. It will fade, slowly, patently, almost imperceptibly. This period, known as the asterisk degenerate eras, will last for approximately 10 furry years. To appreciate that number, consider this: the universe today is about 13.8 billion years old. Compared to 10 phonophore years, its entire history is less than the first fraction of a second on a clock that will never finish ticking. Everything humanity has ever known exists almost entirely within the opening instant of cosmic history. We often think of ourselves as living late in the story. In reality, we're still witnessing the opening pages, yet even those pages will eventually turn, because gravity has one final act remaining. As stars die and galaxies continue to evolve, the largest surviving objects begin swallowing everything around them. Black holes become the dominant structures in the universe. At first glance, they seem immortal. They consume light itself. Nothing appears capable of escaping them. For decades, physicists believed they might survive forever. But then one extraordinary idea changed everything. A discovery that revealed even the darkest objects in existence are not exempt from the universe's final rule. Even black holes can die. Now the real question begins. For centuries, we've assumed something so obvious that we almost never stop to examine it. We assume that forever is always better, that eternity is superior to finitude, that if an all-powerful creator existed, the greatest possible universe would be one that never ends. It feels like common sense, but common sense isn't always true. Sometimes it's simply the story we've repeated for so long that we've forgotten to question it. So let's do something unusual. Imagine a universe that never dies, no entropy, no decay, no irreversible change. Nothing wears out, nothing ages, nothing is ever truly lost. At first, it sounds like paradise. But physics invites a different question. Could such a universe actually contain life? To answer that, we need to understand something surprisingly simple. Life doesn't exist in spite of change. Life exists because of it. Every living cell survives by exploiting differences: a difference in temperature, a difference in chemical concentration, a difference in electrical charge. Your body is constantly moving energy from one place to another, converting highly ordered energy into less ordered forms while using that flow to stay alive. Every heartbeat, every breath, every thought depends on energy moving in one direction. If every part of the universe were already perfectly balanced, if there were no gradients to exploit, no hotter, no colder, no higher, no lower, then nothing could happen, not because the laws of physics disappear, but because there would be no usable energy left to drive any process, no metabolism, no circulation, no growth, no brains, no observers. In modern physics, life isn't separate from the universe's thermodynamic story. It's one expression of it. Living organisms create local pockets of extraordinary order, but only by increasing the total entropy of their surroundings even more. In other words, life is possible because the universe is still running downhill. And the same is true for your mind. Every memory stored in your brain depends on irreversible physical processes. Neurons strengthen connections, chemical signals cross tiny gaps. Electrical gradients build and collapse thousands of times every second. These events unfold in sequence, one after another, past becoming present, present becoming future. Without that direction, memory loses meaning. Cause and effect blur together. The distinction between before and after disappears. Time itself ceases to have the structure that conscious experience depends upon. This is where physics quietly intersects with something deeply human. Think about the moments that have mattered most in your own life. A graduation, a goodbye, the birth of a child, the final conversation with someone you loved. Why do those moments carry such weight? Not simply because they happened, but because they could never happen again. Scarcity gives moments significance. A sunset is beautiful partly because it fades. If daylight never ended, the evening sky would become ordinary. Music moves us because each note disappears the instant it's played. If every note lingered forever, melody would dissolve into endless noise. Even language depends on sequence, one word replacing another, one sentence giving way to the next. Meaning itself unfolds through time. Of course, these observations don't prove that the universe was designed this way. Science cannot measure purpose. It can describe structure, it can reveal consequences. It can tell us what follows if the laws are arranged one way rather than another, but asking why those laws exist at all takes us beyond physics alone. Still, the picture that's emerging is difficult to ignore. The very processes that guarantee stars will eventually burn out also make stars shine. The same thermodynamic flow that ensures galaxies evolve also powers chemistry. The same arrow of time that carries everything toward an ending also makes memory, biology, history, and consciousness possible. The ending and the beginning are not separate stories. They're opposite ends of the same process, which leads to a possibility few people consider. Perhaps the universe doesn't possess meaning despite being temporary. Perhaps its temporariness is part of what makes meaning possible. Not because endings are inherently good, no one celebrates loss for its own sake, but because a world in which nothing could ever be lost might also be a world in which nothing could ever truly be cherished. Whether you see that as a profound coincidence, a consequence of deeper physical laws, or the fingerprint of a creator, depends on the worldview you bring to the question. Sensings can take us to the edge of that mystery. What lies beyond it is philosophy, perhaps theology, and perhaps something neither discipline has fully captured yet. We've come a long way. We began with a simple observation: the universe will end. Not suddenly, not dramatically, but inevitably. Every star will exhaust its fuel. Every galaxy will fade. Even the last black hole will eventually disappear. The laws of physics point toward a universe that is temporary, but what that means depends entirely on how you interpret it. There are, broadly speaking, three ways to read the story. The first is the view embraced by much of modern science. There is no deeper meaning behind the universe's finitude. Entropy increases because systems with enormous numbers of particles overwhelmingly evolve toward more probable states. Stars shine because nuclear fusion follows the laws of physics. Life emerged because chemistry, given enough time and the right conditions, became biology. Consciousness evolved because organisms capable of modeling their environment survived more effectively than those that couldn't. There is no hidden purpose, no cosmic intention. The universe simply unfolds according to impersonal laws. Its ending is neither tragic nor meaningful. It is simply what happens. This view is intellectually rigorous. It explains an extraordinary range of observations without appealing to anything beyond the physical universe itself. But for many people, it leaves another question unanswered. Why do these particular laws exist? Why these constants? Why a universe capable of complexity at all? Science describes how reality behaves. It is less equipped to answer why reality exists in the first place. That brings us to the second possibility. Perhaps there is a deeper principle we have not yet discovered. Throughout history, physics has repeatedly revealed unexpected layers beneath familiar phenomena. Gravity, electromagnetism, relativity, quantum mechanics. Each revolution showed that reality was stranger, and more elegant than anyone had imagined. Some physicists have wondered whether consciousness itself may eventually be understood as part of a deeper framework connecting information, thermodynamics, and the structure of space-time. At present, these ideas remain speculative. No accepted theory unites them, but history cautions us against assuming we've reached the final chapter of scientific understanding. Perhaps one day we'll discover that a universe capable of observers must possess precisely the kind of thermodynamic history we see around us. Not by design, not by chance alone, but by necessity, a logical consequence of reality itself. And then there is the third interpretation, the oldest, and perhaps the most provocative. Suppose there is an eternal creator, not a being inside the universe, but the source of its existence. If such a creator could choose among infinitely many possible realities, why choose this one? Why create stars destined to burn out? Why create civilizations that rise and fall? Why create people who love, knowing every goodbye will hurt? Perhaps because permanence was never the goal. Think about the greatest stories ever told. Every one of them has an ending, not because the author lacked imagination, but because the ending gives meaning to everything that came before it. A novel with no final page isn't infinite, it's unfinished. A symphony that never reaches its last note eventually stops being music, it becomes background noise. Completion isn't the enemy of beauty, it is what allows beauty to exist. If that analogy holds even imperfectly, then perhaps a finite universe is not evidence of limitation, perhaps it is evidence of intention, not proof. Intention cannot be measured with a telescope. It cannot be derived from Einstein's equations or detected inside a particle accelerator. But it remains a philosophical possibility that physics alone cannot eliminate. And notice something remarkable. All three perspectives begin with exactly the same observations, the same stars, the same entropy, the same expanding universe, the same mathematics. Where they differ is not in the data. They differ in what they believe the data ultimately signifies. One sees necessity without purpose. Another sees a deeper law still waiting to be discovered. The third sees the signature of a mind behind the laws themselves. Physics cannot choose among them, nor should it pretend to. Science is at its strongest when it explains what can be tested. Philosophy asks what those explanations imply. Theology asks whether those implications point beyond the universe. These are different questions. Confusing them weakens all three disciplines, yet together they lead us back to where we began. An infinite God, a finite universe. Perhaps that apparent contradiction isn't a contradiction at all. Perhaps infinity didn't create something temporary by mistake. Perhaps it created something temporary because only the temporary can experience urgency. Only the temporary can experience sacrifice. Only the temporary can experience hope. Only the temporary can know what it means to choose today instead of tomorrow. If nothing could ever end, would anything ever truly begin? That is not a question physics can answer. But it is a question physics makes impossible to ignore. Tonight, somewhere above your head, a star is dying, not violently, not in a spectacular explosion, just quietly every second. Deep inside its core, hydrogen atoms fuse into helium, releasing the light that has traveled across unimaginable distances before reaching your eyes. That light may have begun its journey hundreds, thousands, even millions of years ago. By the time it touches your retina, the star that produced it may already be different from the one you're seeing. You're looking into the past. Every star in the night sky is a message from another time. And every one of those messages carries the same truth. Nothing in this universe lasts forever. Not stars, not galaxies, not civilizations, not even the universe itself. At first, that realization feels unsettling. We're instinctively drawn to permanence. We build monuments hoping they'll outlive us. We preserve photographs to hold on to moments that have already slipped away. We write books because memory fades. We tell our children stories that were once told to us. In countless ways, we resist the passing of time. Yet it's worth asking, if nothing ever faded, would we notice anything at all? Imagine a world where every flower bloomed forever. Would anyone stop to admire a blossom? Imagine a song that never reached its final note. Would it still be music, or simply endless sound? Imagine a life with unlimited tomorrows. Would today carry any urgency? Would forgiveness matter? Would courage? Would love? The value of a moment often comes from knowing it cannot be repeated. Its fragility is inseparable from its beauty. Keynes's doesn't tell us that this is why the universe is finite. But it does reveal something extraordinary. The same laws that ensure every star will one day fade are the laws that allow stars to shine. The same flow of energy that guarantees an ending also fuels every sunrise, every growing forest, every heartbeat, and every thought you've ever had. The universe doesn't become meaningful despite its mortality. Its mortality is woven into the very processes that make meaning possible. Whether that is simply how reality happens to work, whether it reflects a deeper principle that science has yet to uncover, or whether it was intentionally chosen by a creator, remains one of humanity's oldest and most profound questions. Each answer carries its own vision of reality. Each invites a different way of seeing our place in the cosmos, but regardless of which view you hold, one fact remains unchanged. You exist during an astonishingly brief chapter in cosmic history. For nearly 13.8 billion years, the universe evolved toward a state where stars forged the elements of life, planets formed, oceans appeared, chemistry became biology, biology became consciousness, and somewhere on an ordinary planet orbiting an ordinary star, the universe became capable of asking questions about itself. That may be the most remarkable fact of all. The atoms in your body were forged in ancient stars. The oxygen you breathe was created in stellar furnaces billions of years before Earth existed. The calcium in your bones, the iron in your blood, the carbon that forms every cell of your body, all were born long before you. In a very real sense, the universe spent billions of years learning how to become conscious through beings like us, not because science has proven that was its purpose, it hasn't, but because that is what happened. And now, for a fleeting moment between the beginning and the end, you are here, able to wonder, able to imagine futures you'll never see, able to look into the night sky and ask questions older than civilization itself. One day, our sun will fade. Long after humanity is gone, the galaxies will grow dark. Eventually, the final stars will disappear. The last black hole will release its final whisper of light. Then the universe, as far as physics can presently describe, will enter an age of unimaginable silence. If that is the future, then this moment is unimaginably rare. This conversation, this breath, this heartbeat, this chance to stand beneath a sky filled with stars. Perhaps the greatest mystery isn't that the universe will one day end. Perhaps the greater mystery is that, for this brief and extraordinary moment, it is alive with light. And somehow, so are we. So the next time you look up at the night sky, don't just see distant stars, see time itself unfolding, see the atoms that became worlds, see the ancient light that crossed millions of years to reach your eyes. And ask yourself the same question that has echoed through science, philosophy, and faith for centuries. If an infinite God chose to create a universe that ends, what was so precious that it could exist only in something temporary?